In this lesson, we're going to learn about kinetic molecular theory. So the theory states that gas particles are spaced far apart, which means that there is a lot of empty space between the particles. It tells us that gas particles are constantly moving. They're moving very fast and in a straight line. And that straight line, remember, is called translational motion, and that results in elastic collisions between different gas particles, and because the collision is elastic, there's no loss of kinetic or movement energy. There aren't any forces of attraction or repulsion between different gas particles, and so that's why they are able to spread apart, and that results in a lot of empty space between them. And the temperature of a gas is proportional to the average kinetic energy of the particles. So if we take a bunch of particles, measure their kinetic energy, take the average, there's a relationship there with the temperature. So temperature essentially measures the kinetic energy, but not the total amount of energy between the particles, the average of their kinetic energy. So that means that the more particles we have, each at the same temperature, the more overall energy there would be. Atmospheric pressure. So there is a force that's exerted on the Earth's surface by the air. And the further up we go, or as we increase in altitude, there are fewer gas molecules in the air, and so pressure decreases. So we can see that there is a lot of molecules or particles down near the Earth's surface, and that results in a higher pressure, and the further we move up and away from the Earth's surface, the more space there is between particles there, and so the less pressure there exists there. So when we talk about pressure, there are many different units for measuring pressure. The three that we are going to focus on are atmospheres, milligrams of mercury, and kilopascals, and this gives us the conversion between them. So 1 atmosphere is equal to 760 millimeters of mercury, and that is equal to 101.3 kilopascals. So milligrams of mercury, if you think of a thermometer in that tube, there is mercury, and each millimeter would represent a certain temperature. So it may represent a 0.1 increase in the temperature that is being measured. And so that is created based on the change in pressure with temperature. And so milligrams of mercury is literally measuring in that tube, not milligrams, millimeters, the distance that mercury will move up that tube. Okay, so we're going to practice converting between those units of measurement. So first we have 350 millimeters of mercury, and we're going to convert that to kilopascals. So we've got the conversions over here. So if I start with 350 millimeters of mercury, what I'm going to use is the relationship between millimeters of mercury, and I want to move to kilopascals. So I want the millimeters of mercury on the bottom so that I can cancel. So remember, this is called the unit factor method. Allows me to cancel that, and that is equal to 101.3 kilopascals. So within this fraction or this ratio, these two are equal. So 101.3 kilopascals is equal to 760 millimeters of mercury. So that will give me 46.7 kilopascals. So 350 millimeters of mercury is equal to 46.7 kilopascals. Next one, I'm going to convert from atmospheres to millimeters of mercury. So I want my answer in millimeters of mercury, so that's on the top, and I want to cancel out atmospheres, so that's going to be on the bottom, And my relationship is that every 760 millimeters of mercury is equal to 1 atmosphere. So I have 1.4 times 760, which is equal to 1,064 millimeters of mercury. And the last one we'll look at is 108 kilopascals. And so we want to get rid of kilopascals and we want to convert to atmospheres. So 1 atmosphere is equal to 101.3 kilopascals. So 108 times 1 divided by 101.3 is equal to 1.07 atmospheres. So kilopascals would cancel there.